What's up, you freaking geniuses? So in this video, I'm going to teach you how to determine if two linear equations are parallel when you graph them, okay? Now, in order to be able to do this, you need to be familiar with the slope-intercept form of an equation, which it's this thing right here. Y is equal to mx plus b, okay? Now, if you need a quick review on this, I'll link a video to that in the card above, but I'll at least briefly explain kind of the basics here. So the first thing you need to know is that this variable right here, the m, stands for the slope, okay? And then this variable at the end right here, this b, stands for your y-intercept. Okay, so for two equations to be parallel, they have to have the exact same slope, okay, but different y-intercepts, okay? So this number right here that's next to the x has to be the exact same on both of the equations, but this number at the very end has to be different, okay? So let me give you an example. So if we were trying to figure out if these two equations were parallel, so let's use y is equal to 2x plus 1 and y is equal to 2x minus 7. Okay, so are these two equations parallel? Well, again, in order for them to be parallel, they have to have the same slope. And again, the slope comes from this number that's right next to the x. Okay, so there's a 2 here. And right here, next to this x, is also a 2. Okay, so since they both have a positive 2, right, same sign and everything, that means they have the same slope. Okay, so the slope for both of these is equal to 2. Or if you wanted to, you could write it as 2 over 1, okay? Because your slope, the definition of a slope is equal to the rise over the run, right? So since we have a fraction right here, normally it's better to write your slope as a fraction also, okay? So you can just put it over 1. Okay, so they both have the same slope, and now we just need to figure out if they have different y-intercepts, which they do, right? Because this one on the left has a y-intercept at positive 1, and this one has a y-intercept at negative 7, okay? So they have the same slope, but different y-intercepts. So that means these two equations are parallel, okay? And we can also graph these just to prove that. So we'll say this is the first equation right here, and then this is the second equation. Okay, so first of all, let's graph this first equation really quick. So y is equal to 2x plus 1. So in order to graph these equations, it's actually not too bad. The first thing you want to do is graph your y-intercept, okay? Now your y-intercept is just the point along the y-axis that your graph intersects. Okay, so for example, if this is at positive 1, all you need to do is plot a point on your y-axis at positive 1, which would be right there. Okay, that's all you got to do. Now, if you're going to graph your slope, which again we found was 2 over 1, all you need to do is apply this slope right here, starting at your point that you graphed, okay? So your slope right here, 2 over 1, means we're going to go up 2 and then over to the right 1 time, okay? So again, starting from the point we plotted, we're going to go up 2, 1, 2, and then over 1, 1. Okay, so we just found another point that lies along our graph. So in order to graph a straight line, all you need are 2 points. So I'm just going to draw a straight line between these two. Okay, so this line right here represents this first equation right here. So I'll just label it as number 1. Okay, now let's do number 2 really quick. So y is equal to 2x minus 7. Okay, so again, the first thing, or the easiest thing you can do, is just plotting your point right here at the y-intercept. So your y-intercept in this case is negative 7. So you're just going to come along your y-axis and plot a point at negative 7, which is right there. Okay, cool. We found one point, right? Now the second thing we're going to do, just like we did in the last one, is apply our slope. So again, our slope is 2 over 1. So again, we're starting from this point right here, we're going to go up 2 and then over to the right 1. Okay, so again, starting from this point, we're going to go up 2, 1, 2, and then over 1, right there. Okay, so again, we found a point that runs along through our graph right here. So we have our 2 points. So now we just need to draw a straight line between them. Okay, so then this is the graph of our second equation. Okay, and as you can see, they are exactly parallel. All right, so hopefully that wasn't too bad. Let's just try one more example that's just a little bit harder. Okay, so here is the second example. So these are the 2 equations we're going to check to see if they are parallel. So negative 3x minus 2y is equal to 6, and y is equal to 3/2 x plus 1. Okay, so first thing you want to do is make sure that they are both in slope-intercept form. And if you remember what that is, it's y is equal to mx plus b. Okay, so as you can see, this second equation is already in slope-intercept form, right? Because we have y is equal to, right? Y is equal to some number times x, right? Some number times x plus b at the end, or plus a number at the end, right? Which is what we have here, plus 1. Okay, but this is not in the same form. So we just need to put it in slope-intercept form before we can compare them. Okay, so let's do that really quick. So in order to do that, we basically just need to isolate y by itself on one side of the equal sign, right? Because that's how the slope-intercept form is, right? It's just y by itself on one side of the equal sign. So in order to do that, the first thing I'm going to do is get rid of this minus or negative 3x. So I'm going to do that by adding 3x. And what you do to one side, you do to the other, right? So then these 3x's, they just cancel out. So we're just going to be left with negative 2y is equal to 6 plus 3x, right? 6 plus 3x. Okay, we're almost there. Now we just need to get rid of this negative 2. And in order to do that, we're just going to divide by negative 2. And again, what we do to one side, we do to the other, right? And I have to divide both of these numbers by negative 2. So divide this one by negative 2 and this one by negative 2. Okay, so now on this side, this negative 2 is going to cancel out with this negative 2. So we're just going to be left with y right here on this side. And then that's going to be equal to 6 divided by negative 2. That's equal to negative 3, right? And then here we have positive 3x divided by negative 2. That's going to be equal to negative 3x over 2. Or I could write this a little bit differently. I could write it as minus 3/2 x, like that, okay? Now, this is almost in slope-intercept form, but as you can see, we have to put the term with the x first, and then we put the number at the end, right? So we just have to flip these. So this is going to be y is equal to negative 3/2 x, right? Negative 3/2 x, and then we'll put this minus 3 at the end, minus 3. Okay, cool. So now this is in slope-intercept form. Okay, so this is the first equation that we're going to look at. And then we're comparing it to this second equation right here, right? And I'll just rewrite it down here. So y is equal to positive 3/2 x plus 1. Positive 3/2 x plus 1. Okay, so this is the second equation. Okay, so again, the 2 things that you have to look for in order for these to be parallel is that they have to have the exact same slope. So in this first equation, the slope is negative 3/2, right? And in this second equation, it's positive 3/2. Okay, so they're both 3/2, but the one on top is negative and the one on the bottom is positive. So they are not the exact same slope, right? They are different. So since they don't have the exact same slope, that means these 2 lines, these 2 equations are not parallel, okay? And then just to remind you, the other thing that we would have had to look for is that they have different y-intercepts. So this one's at negative 3, this one's at positive 1, so that checks out. Those are fine. But again, the slopes are not the exact same, so these are not parallel. So if you found the video helpful, definitely leave a thumbs up down below. And if you have any other questions or want to see any other examples, just let me know in the comment section below. Also, there's a couple playlists attached that I think you'll find helpful, so definitely check those out, and I'll see you there.